The foundation detail of the passive house is extremely important. It not only needs to have insulation under the floor, it needs to be continuous with the insulation going up through the wall. What we've got here is underneath the slab we have 300mm of high performance polystyrene insulation, and this needs to be continuous up to the wall. What we've done here is at the edge detail here we have continued as much polystyrene as we can up through the cavity between the slab and the external brick plinth. Between here we have no wall ties at all. It's completely self-supporting. We had some discussions with the timber frame manufacturer on the detail at this point, where traditionally they would have a timber sole plate put down at the bottom and then the timber frame from there onwards. We wanted to try and avoid the cold bridge of the thickness of the timber sole plate at this point. So what we've convinced them to do was to reduce that down to the standard I-beam that they'll be using in the walls, which is then supported on the inside on the edge of the concrete slab, and on the outside on the brick plinth. The other things you can probably see here is all the DPCs and DPMs all being lapped and stuck down, which is very important. But you can also see, again, the airtightness tapes on the corners, and particularly the airtightness tape joining the OSB to the floor at the base. We have also on the outside of the building the board here, which is an Agipan DWG board, which is a breathable, wind-tight membrane, which has been carefully joined together and sealed with a non-setting mastic to form another airtight barrier. And you can just see some of the non-setting mastic called Butty Rub, sealing all the joints around the edge. The structure of the passive house that we've chosen here is a timber frame, mainly due to the timber cladding on the outside and making it an easy way to fix the timber cladding to without increasing the cold bridging of the fixings to a large extent. The I-beams that it's made of, you can see, is basically a 50 by 50 timber post on the inside and on the outside, fixed together with a wood fibre board in the middle to hold them in place. This goes up the wall on the side. On the inside there, we then have an 18mm of OSB 3, which is acting as the airtight membrane, which is taped at the junctions with a Tescon No. 1 tape. On the inside of that, because this forms the airtightness barrier, we have a service void formed by these 38mm battens, which will then be plasterboarded. This allows all the electrics and all the electric sockets to be fitted without any real problems. Obviously, as this is the airtightness barrier, it's very important that nobody makes any particular holes in it. What you can find is that people may put a nail or a screw in and it's in the wrong place and take it out. So what's very important is for the electrician at that point to say, I've done it wrong, or I've made a hole, can I have some tape, and we'll tape it up. So they'll tape up any holes to make sure there's no losses. You can see a couple of places over here where obviously the electrician, for instance here, the electrician put the socket in the wrong place. So again, not a big problem, let people know, tape it up. The passive house obviously has to be very airtight, so keeping the penetrations and the service holes through the airtightness barrier to the minimum is very important. Obviously we still need to do some. As you can see here, we have the water coming in, and what you can see also is the amount of insulation around the pipe coming in. This will be taped up later to make sure it's completely airtight, but the amount of insulation from the pipe down needs to be at least 1 metre to reduce the cold bridging and potential condensation. And again, with the back here, you can see the SVP pipe coming in, which is insulated on the inside and below ground. Again, the airtightness is very important. If we look at the pipes and the cables coming through, where we have the electric meter on the outside, there are obviously some penetrations that are needed. You can see the airtightness grommets and the tape, again, forming the airtightness barrier for all the cables. It's quite important to make sure that you don't try and put a huge number of cables through in one go, because trying to get it sealed between them is almost impossible. Here on the outside you can see the airtightness grommet is fixed so that the cable passes through an EDPM rubber seal to make sure that the airtightness is kept maintained. The windows in the passive house. The The windows are a very important part. The frame being the weakest part in the whole building, and it also doesn't benefit from the advantage of having sunlight coming through to heat the space, so it's not actually achieving as much as the glass is. So the plan is to cover up as much of the frame on the outside with insulation as possible. As you can see on the outside here, the boarding coming out to the edge, which is going to be filled with insulation, and then a timber cladding cover strip on the edge right up to the edge of the glass. The other important thing with the windows is to make it as airtight as possible, keeping the air leakage and drafts and stuff to a complete minimum. We'll have a look at the windows in a minute, but you can see that the actual fittings have at least 2 seals to keep it completely airtight, and so the junction between the airtightness layer on the inside, which is the OSB, and the window frame is very important. You can see here the Tescon #1 tape used to seal the gap between the frame and the OSB, and the corner of the OSB again taped in to form a complete airtightness type junction. If you look at the optic window, obviously this is still being fitted in, there'll be handles and so forth. You can see on the window itself it has 2 seals to keep it as airtight as possible, and the action on the window will be both opening inwards and tilts down for ventilation. The reason the windows open inwards, which is quite a European thing to do, and unlike most of the windows in the UK, is the fact that it means we can put the insulation right up against the outside of the window frame, and it doesn't obstruct it. So we can insulate it to a much higher standard and get much better thermal performance.